we have already discussed 7-layer OSI model. That was an ideal model. But now we are discussing practical model, that is TCP IP model. This is a 5-layer model. We have discussed in OSI model, there is an application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. But in TCP IP model, there will not be any presentation layers and session layers. These two layers are discarded in the TCP IP model. Here in TCP IP model, in the application layer, we are using SMTP, FTP, DNS, HTTP, Telnet. To access these services, we are using this application layer. Basically, TCP IP model is the basis of the internet. It runs with mainly two protocols. Transmission control protocol, second one is internet protocol, TCP IP. In 1970, this was introduced. This will try to utilize the transmissions in the internet network. So the transmissions in the internet network are handled by the TCP IP model. Nowadays, without the internet, we cannot find it is possible to use any email or WhatsApp, whatever the services you are using. That is because of the internet. The basis of the internet is TCP IP. Here we are using in the application layer, as we discussed, for these to access these services, to access these like HTTP hypertext transfer protocol, we will discuss in the next coming topics. To access the network for these types of the services, we need the application layer. From this application layer, the message we are sending to the transport layer. In the transport layer, end-to-end data communication will happen. Error controlling and data flow control is possible in the transport layer. Transport layer is represented mainly by the two protocols. One is TCP and the second one is UDP. TCP is nothing but transmission control protocol and UDP is nothing but user datagram protocol. TCP is a reliable connection oriented protocol, means the source and the destination, they should be connected first, then only data will be transmitted. If there is no connection established, there is no transmission. That's why it is called as a reliable connection oriented protocol. Whereas in the UDP, it is an unreliable connection oriented protocol. Means the source says, I will send the data. It does not bother to me whether the destination is connected to me or not. First I am sending the data. If the destination is connected, it will receive. If it is not connected, the data will be lost. So this is unreliable. We do not know really the data reached the destination or not. Because without establishing the connection, we are sending the data. But the advantage of this protocol is it is speed. There is no need to wait for the connection. It will first send the data. Later, if it is connected, it will receive. And in voice and multimedia applications, we require this type of the protocol, UDP. For the text, we can go for the TCP. Now next, the data, the message in the TCP, the message in the TCP IP, the message from the application layer, it is sent to transport layer. Transport layer, it will divide the message into segments. That is what we are calling as a user datagram. In the transport layer, we are using these two protocols, TCP and UDP. That segments of the message we will send to network layer. In the network layer, mainly we are using the internet protocol. That's why it is also called as internet layer. Here, routing of the data is possible. Direction to data, where the data has to move to which point, the direction will be given in the network layer. As we already discussed in the OSI model, whenever the data is coming to the network layer, the data is in the form of the packets. We are calling that as a datagram. We will discuss in the next topic what is actually datagram. So IP packets are sent to the destination. Next, these packets we are forwarding to data link layer. This data link layer will further convert the packets into frames. It will add header and tile. And finally, physical layer, it will extract the raw bits information and it will send the bits onto the cable. Receiving side, physical layer will convert the raw bits into frames, and the data link layer converts the frames into packets, and the network layer converts the packets into segments, and the transport layer converts the segments into message, and finally application layer will deliver that message. We are using some more protocols like address resolution protocol in the network layer. What is the use of this address resolution protocol? The IP address of the host is the input, and the physical address is the output when we are using the address resolution protocol. Similarly, when we are using the RARP, physical address is the input and the internet protocol address is the output. ICMP, it is the error representation protocol. These are the different protocols in the network layer. We are repeating once again the important points. In order to access these services, in the application layer, we are sending the message to transport layer. Transport layer will convert this message to segments by using the TCP and UDP protocols. TCP is a reliable protocol, reliable connection oriented protocol. There should be connection between the source and the destination before the data transmission. Whereas in the UDP protocol, there is no need of the data connection between the source and the destination for the data transmission. Next, that segments are sent to the network layer. Here the segments are converted to packets, and the packets are finally converted to frames by using the data link layer, and these frames are converted to bits by using the physical layer. At the receiving side, this process will be reversed. This is the working of the TCP/IP model.